Check, check. Hello. Hi, everybody. So first of all, I just wanted to thank Luis for giving a fantastic talk. This is, it's a bit hard to follow that, and I want to thank them for their efforts and just really leading the way in terms of reminding projects in the space that we are trying to build a decentralized future. We are trying to build public goods that are governed by communities in general. And I really think that Aragon's setting a fantastic standard and really being a vanguard for this. So my name's Nadav. I am the founder and CEO of Dharma Labs, which is building Dharma Protocol. And this talk is called Dharma and the Power of Open Financial Primitives. So first of all, just as a quick poll of the audience, could you just raise your hand if you've heard of Dharma before and what we're doing? Okay, fantastic. I love seeing that number of hands go up every time. So for those of you who have not heard, Dharma is a protocol for borrowing and lending tokens. In quick summary, we've been live on the Ethereum mainnet since May of 2018. Something around 150K in peer-to-peer loans have been issued with Dharma so far. And 3 awesome businesses have been built on Dharma that are on mainnet today that you can go play with right now. So in this talk, we're going to cover, first of all, why did we build this? Like, what's the point of this whole thing? Number 2, how it works. I'm going to try to give you guys kind of a high-level overview of it. And then finally, number 3, how to get started. So if you're a hacker here and you're looking to build a project, we've got a whole suite of developer tools and starter kits that you can use to get up and running right away, building a dApp. So why did we build this? So I'm going to talk a little bit about debt. And I'm going to make a claim that the world economy runs on debt. Now, debt has a very kind of negative-loaded connotation to it. We think about things like student debt or our credit card debt. But I'm going to make an argument that it's actually kind of a very double-edged sword in a sense. The houses that we sleep in are funded by mortgages. The cars that we drive in are funded by auto loans. The businesses that employ us stock inventory using debt. The infrastructure we build is funded often by municipal bonds. The education we receive is funded by student loans. And even the states that govern us rely on debt fundraising in order to kind of keep their day-to-day operations going. So it seems like so many parts of our lives are funded by debt. And the kind of machinery that operates in the background to enable this system to work is what we refer to as the world's debt capital markets. This is basically like the system in which different debt agreements are issued and traded. And this happens a lot. So if you kind of look at the far left here, we have the total market cap of crypto. I think it's actually kind of funny. I've given this talk a couple times already, and every time I think that I need to update the total crypto market cap, but then the market just turns and goes back to that $200 billion number. So you guys got to like stop giving me talks because it's just like a bad luck thing. And then we have the total equities market cap over here, which is around 65 trillion. Clearly, us in the crypto community have a long ways to go to catch up. But on the right, we have this huge figure, which is the global debt market cap, right? Like this encompasses all the world's mortgages, all the world's sovereign debt, et cetera. And it hovers at around like 2.5 times the size of the world's total equities market cap. However, debt capital markets have several serious flaws. So first of all, they're really inefficient in several respects. So if you think about what a debt agreement is, it's basically just like a legal document, right? It's essentially a legal document that a borrower and lender sign that says, I promise to pay you back X amount of dollars, and if I don't, then Y default conditions are going to happen, and you're going to do some bad things to me. But the problem is with legal contracts is that I'm sure this resonates with you guys. They're very messy and non-deterministic, unlike smart contracts, right? And when you have these kind of textual legal contracts and something goes wrong and the happy case doesn't happen, then you need to bring in lawyers to essentially adjudicate the situation, and those lawyers tend to extract rent from the process. The other problem is that essentially if you want to be able to have a debt agreement that is tradable in some capacity so that there's a secondary market for it, then essentially somebody needs to keep track of who owns that debt agreement at any given time, so that if a borrower makes a repayment, funds are properly routed to the actual owner. These entities in the financial system are known as paying agents, and similarly, they kind of sit in the middle and extract rent from the process. And then finally, we have these guys called escrow agents. So the vast majority of the world's debt is in some way collateralized or secured, which means that the borrower has to put up some asset, and essentially, if they do not pay back their loan, then that asset is going to get seized. And the problem with the traditional financial system is that you essentially need to have some sort of trusted third party custody that asset if you want the agreement to be like quote unquote secured. And these are known as escrow agents, and similarly, the extract rent. And so you have all these different parties who are sitting in the middle extracting rent from that transaction, and at the end of the day, the person that's paying for that rent is you guys. It's the borrowers and the lenders. It's the end users of this system. And so that translates to more expensive debt agreements. So the second kind of big category of flaws within debt capital markets is just a notorious proclivity towards opaqueness, essentially. So this is a diagram of what's called a CDO, or a collateralized debt obligation. These are incredibly complex financial instruments that I'm not going to give a talk on right now, but they are kind of notoriously known for precipitating the 2008 financial crisis. And one of the big issues with them is that it's not like there's anything inherently wrong with taking loans and bundling them together and creating sort of derivative credit instruments. It's just that these things were like insanely obtuse and difficult to analyze, so much so that only rating agencies really had the ability to peer into them. And there was all sorts of incentives issues around whether these ratings agencies actually had an incentive to rate them correctly. And then, 2 or 3 steps after that, you end up with a financial crisis. And so essentially, debt markets are hugely lacking in transparency. But finally, and most importantly, I would argue that debt markets lack universal accessibility. And I'm going to point out a few interesting data points with respect to this. So first of all, many of you have probably heard this figure before. There are over 2 billion adults in the world who are either unbanked or underbanked. But a lot of them are rapidly coming online through commodity smartphones. The problem is that it's not like if you're in a village in India, you can go onto lendingclub.com and take out a loan from the United States. Or say go onto a Chinese peer-to-peer lending site and lend your money out in their capital markets. And the reason for this is that while HTTP has no concept of borders, i.e. you can go and load up all of these web pages, our financial system very much does. So if debt capital markets are lacking in efficiency, in transparency, and universal accessibility, how can we build something better? Naturally, we believe blockchains are the missing piece of this puzzle. Blockchains give us the tools that we need to build credit markets that are much more efficient, much more transparent, and much more universally accessible. So starting with efficiency, you can use blockchains to essentially create loans that are entirely peer-to-peer and are entirely administered by a smart contract. So there doesn't need to be a paying agent. There doesn't need to be a lawyer who adjudicates what happens when the collateral needs to be seized. And there doesn't need to be any sort of escrow agent. Number 2, they're just radically transparent by default. So right now, if you go onto loanscan.io, you can see all of the loans that have ever been issued via Dharma, and you can see the default status of all of them. You can see kind of what risk they were underwritten at, how much they were over-collateralized, et cetera. All of this stuff is entirely visible, so you have this kind of root-level transparency. And then finally, universal accessibility. This is the really exciting part. These tools are effectively accessible by anyone, anywhere with an internet connection, which is a really exciting prospect. So how does all this stuff work? So at a high level, I like to think of Dharma as kind of being this financial middleware layer that sits between the Ethereum blockchain and end-user applications that are basically storefronts for lending. So, applications that let people borrow or applications that let people lend their money out or earn interest on their money. And I'm going to break this down into 3 easy steps. And the first one is essentially we need to define the terms of a debt in some capacity. So the way that we do that in Dharma is using something that we call a terms contract. Basically what a terms contract is kind of this template that defines a sort of type of loan agreement. And that template is literally just like a smart contract that adheres to a certain solidity interface. And what's cool about this is that essentially if it implements the methods in that interface, then you kind of have all the information that you need in order to programmatically query it and figure out what the terms of this debt are, like i.e. how much is expected to be repaid at which time, and what happens if the person defaults. So I really like to think of a terms contract as basically being like a loan template that's deployed onto the Ethereum blockchain. And if you want to essentially take out a loan, you say like, I'm going to use this loan template with XYZ parameters filled in. So that's great, but now you've got to actually express that intent somehow so that somebody can find you and fill that loan. So this is where the concept of a debt order comes in. So basically what a debt order is a signed message that indicates that you as a borrower want to take out some loan according to the terms defined in a terms contract. So this is kind of an abridged version of what a debt order looks like, but essentially you see that the person requests their desired principal, they point to a certain terms contract's address, and then they list out the parameters that kind of fill in the blanks there. So if you imagine like the terms contract parameters would essentially be what go into all the blanks right there. So we've expressed our intent, now what do you do? So here's what you can do with a debt order if you already have some sort of counterparty or you already have somebody that's willing to lend you money. So suppose we have Alice and Bob, the canonical example. Alice has 100 ETH, Bob has 100 DAI. So Alice is going to send her signed debt order over to Bob. Bob is going to evaluate it. He's going to check out the terms contract. He's going to check out the parameters. He's going to get this idea of kind of how good of an investment this might be. And then he decides, like, okay, I want to actually fill this debt order. I actually want to lend money for an interest rate to Alice. So he's going to submit that debt order to the Dharma smart contracts. And what the Dharma smart contracts are going to do is that they're going to take 100 DAI from Bob, and they're going to transfer them over to Alice. They're then going to go and take 100 ETH over from Alice, custody it as collateral, and then issue Bob a debt token. And what a debt token is basically a non-fungible token representing Bob's rights to receive repayments in this loan at any time in the future. And what's nice about this is that this token is like any other 721, right? It's tradable, it's repackageable, programmable, et cetera. And so essentially you kind of solve this paying agent issue, because now if you want to trade your loan in a secondary market, there doesn't need to be any party that keeps track of who owns that loan now. The quote-unquote paying agent is the Dharma smart contracts that kind of keep track of all this stuff. But unfortunately, not everybody has like a friend that they just know who is like willing to lend them 100 DAI, right? And so you need to essentially find a counterparty to actually fill that order. That's the whole point of debt markets, is that you need to essentially match both sides. So we introduce kind of 2 categories of what we would call keepers in the protocol that are essentially financially incentivized actors that enable this sort of order matching or this sort of market matching. And the first one is what we'd call relayers. And so I'm sure many of you here are familiar with the 0x protocol. This is almost entirely the exact same concept. So basically relayers are some sort of entity that hosts a public order book where people can go and post their debt orders. And if anybody comes along and decides to fill that order, then the relayer is going to earn some sort of pre-specified fee. And these relayers can also optionally share liquidity with one another. So essentially, you effectively have this network of actors that are financially incentivized to host debt orders that can share the liquidity amongst themselves, that when a borrower wants to go and take out a loan, they can broadcast their loan to all the different relayers, and a creditor can come in to one of those relayers and potentially fill that loan. So this is an example of a relayer today. It's called Blockboard. I do believe Vitaly is somewhere here in the audience, the CEO. But Blockboard is the first relayer that went up on Dharma protocol. And you can see that it effectively looks a lot like an exchange, right? It's basically a bulletin board for people to post debt orders on there, and then for different creditors to come in and fund those debt orders. Now, that's all well and good, and that works pretty well when you're dealing with like heavily collateralized assets where you don't really need to like trust the counterparty. But what if there's no collateral, right? What if we're dealing with an unsecured loan? And so essentially for this, we introduced the concept of an underwriter. And effectively what an underwriter does in Dharma protocol is that it's some sort of trusted known entity, think like i.e. a Coinbase or a credit rating agency or some sort of upstart company that starts to do this. And essentially what this underwriter does is that they originate the debt order. So I'm a borrower. I go to Underwriter's website and I tell them I want to take out a loan. They determine and negotiate the actual terms of the debt. And then they cryptographically commit to their perceived likelihood of how likely it is that the borrower is to default on that loan. And so essentially what that means is that you have this kind of flow where Alice instead goes first to the underwriter. The underwriter judges her creditworthiness through whatever means he sees fit, right? He can pull a credit score on her in the real world, or maybe he's got some like fancy cryptographic magic where he looks over all of her history on the Ethereum blockchain and determines creditworthiness that way. The mechanisms by which the underwriter chooses to actually assess the risk aren't explicitly defined in the protocol. The point is that good underwriters ought to be able to get more business because essentially their performance will be seen on-chain as being better. And so now that the underwriter is gone and basically said, like, I believe that this loan has an X% chance of defaulting, they can pass that loan off to a bunch of relayers, and when that loan gets filled, then similarly the underwriter is going to earn some sort of fee. So how do you get started if you want to build something on Dharma this weekend? So we have a whole bunch of libraries and tools and starter kits that you can use to really get up and running in less than 5 minutes. The first kind of big component of that is Dharma.js. Essentially, we wanted to create a system in which all of the complexity of using Solidity smart contracts is kind of abstracted away from you, and you can basically use the same sort of commodity web dev tools that you're familiar with. We have a very thorough developer portal that you can go to find guides about how Dharma works in excruciating detail, all sorts of tutorials, all sorts of ideas for things that you can build, FAQs, API references, etc. We have this awesome thing called the Real Lair Kit that we came out with a couple weeks ago, where essentially you can clone this repo, style it however you like, and essentially spin up a relayer of your own in like 5 minutes. And so we think this is an awesome place to start if you want to build something on top of Dharma. So what can you build this weekend? So first of all, there's a lot of room for more relayers in Dharma protocol that service essentially different types of debt, right? So right now, the majority of loans that we're seeing in Dharma are largely for speculative purposes. It's people like borrowing to either short something or to leverage something. But it would be really interesting to see, for instance, relayers that focus more on security tokens or relayers that are focused on 721s or something that is like not necessarily what we're seeing in the market right now. And speaking of 721s, there's this really interesting concept that we've been waiting to kind of see implemented in that we've actually been building a lot of tools for that we called Collateralized Collectibles. We're essentially, like, I'm sure we're all familiar with things like CryptoKitties and the many different incarnation of NFTs that have emerged since then. And we're familiar with the fact that these things can become incredibly valuable. And so what's kind of interesting about an NFT is that if you think in the far future of what NFTs will be used to represent, it'll probably be used to represent things like houses or like titles for different lands, right? Because that's kind of inherently a non-fungible good. And what you can usually do with something like, say, a house is put it up for collateral and take out a loan against it, right? That's what's known as a mortgage. And so there's this really interesting concept that you can actually implement today using Dharma, where you can create effectively CryptoKitty mortgages, right? Or take any sort of NFT, put it up for collateral, and be able to like essentially take out some DAI against it so that you have some liquid cash that you can use. And so if anybody is interested in building this out, we've actually created like a whole set of like miniature tutorials that aren't like publicly visible on our site right now. So if you guys are interested in building this, come talk to me afterwards, and we'd be happy to support you in that process. Another idea that we're really excited about is just general structured financial instruments, right? So I talked earlier about this notion of a CDO, where you take a bunch of debts and bundle them together and tranche out the cash flows in special ways. And so what's really exciting about using Dharma debt instruments is that you can use a smart contract to package these things up instead of like, $10 million worth of legal fees and an entity in like the Cayman Islands to actually store all the cash flows. And it's just infinitely cheaper to actually administer these things when you have a smart contract doing it. So we're really excited about this idea of structured financial instruments. And then finally, we're really excited about the idea of Dharma Debt Explorers. So essentially the ability to interfaces that let people look at the current volume in the protocol and analyze it in different capacities and kind of slice and dice the data in order to figure out whatever it is that they're trying to look for. So finally, in conclusion, the open financial system is very much in the infrastructure building phase right now, but I feel incredibly optimistic about how fast things are going. In that if you look at this, this picture, pretty much the vast majority of projects on here like didn't exist a year ago. And many of them are already live on the Ethereum mainnet and being used. And all these different primitives are being combined together in order to create fantastically novel financial services and applications, many of which never even existed in the real world. And I think that's really exciting. So let's build a financial system together. Thank you, guys.